I'm Jason Ho. I'm going to present my applied research, Feasibility on Free Cooling for Office Buildings in Hong Kong. Free cooling commonly applies in fortune data center and commercial buildings. This research aims to investigate the adoptability of free cooling technology at Hong Kong office buildings. Free cooling is worked by fully introducing outdoor air, as Hong Kong aims to reduce 65% of carbon intensity by 2030, while it could save around 30% on energy usage. MVAC system design considers radiant temperature, relative humidity, and clothing insulation. The system design aims to achieve 80% of occupant satisfaction and optimum system performance under sustainable life cycle. Literature has been studied to develop deeper understanding. Humidity control and maximum set point is reviewed for system setting. Case study at Germany and control strategy is examined for further monitoring, and payback calculation is learned to evaluate the economic saving. It is necessary to analyze the available days of free cooling and identify occupants' needs on ventilation system. Energy conservation is then estimated with the figures above. Daily enthalpy is plotted from mean drive-up temperature and relative humidity. Free supply air condition 15, 19, and 25.5 degrees Celsius are set up to study their potential on free cooling. The availability of free cooling in 2019 under 15 degrees Celsius is around 9.9%. Under 19 degrees Celsius condition, free cooling is increased to 15.9%. And for 25.5 degrees Celsius set point, free cooling potential is maximized to 27.1%. Gross energy consumption of traditional MVAC system is around 2,300 MWh. Annual energy saving can reach 540 MWh under free cooling application, which saves around 23.3% of annual energy consumption. In the same consequence, carbon emission can reduce 382 tons under free cooling application. During December and January, it takes up 68.7% of annual carbon reduction. Thermal comfort satisfaction is inquired by rating from 1 to 6. Only a quarter satisfied with their work environment that reflects the system performance is poor. Over 60% of respondents experience excessive CO2 concentration, and half of them also found undesired air velocity. Around 40% occupants suffered from displeasing outlet temperature. Corresponding to IAQ enhancement by free cooling, around 35% agreed to the improvement on temperature and relative humidity, and 65% of them assess that CO2 concentration can be improved. Free cooling benefits from energy conservation by 540 MWh and carbon emission reduction by 382 tons. 22 points and 5 points can be attained from BIMPers, energy use and health and well-being respectively. Although free cooling optimizes system performance significantly, actual thermal comfort is necessary to be assessed after building occupation. The system is also needed to meet the design point with energy-saving approach. To further understand the saving potential, geographic advantage is need to be well studied in terms of year-round climate.